The next concept that we'll be learning is basics of computer organization and architecture. So what is computer organization? Computer organization refers to principal components and structures that make up a computer system. It involves how the hardware components are interconnected and operate together. Now let's understand what is computer architecture. Computer architecture refers to the design and structure of the computer system, including the organization of its hardware and software components. It defines the instruction set and the way the system executes instructions. So the components of computer organization and architecture are central processing unit, which is nothing but CPU. Then we have memory, then input output devices and storage devices. First, let's understand CPU. So it's the brain of the computer that performs calculations and executes instructions. Then we have memory, which stores data and instructions that the CPU needs to access. Input and output devices allow interaction with the computers, such as keyboards, mice, and monitors. Next, we have storage devices. Storage devices store data and programs for long-term use, like hard drives and solid-state drives. In architecture, we normally use a single architecture, that is von Neumann architecture, the most common computer architecture design. It consists of a CPU, memory, input-output devices, and a system bus that connects them. Instructions and data are stored in the same memory, and the CPU fetches and executes instructions one by one. So here we have given you a diagram where in the left side you have an input, and in the middle you have CPU, which contains ALU, that is arithmetic logical unit, then CU, control unit, and MU, which is memory unit. And after processing the input, we finally get an output. Next, we have instruction cycle, the basic operation of computer's CPU. Fetch, decode, execute, and repeat. These four are the main operations of a CPU. Fetch. The CPU retrieves an instruction from memory. Then decode. The CPU interprets the instruction and determines the required operations. Then we have execute. The CPU performs the specific or specified operations. Then repeat. The CPU continues to fetch, decode, and execute instructions until the program is complete. Next, let's look into a simple diagram where you have fetch cycle, decode cycle, read cycle, and execute cycle. So it's basically a loop where the whole process keeps on doing. Next, let's understand bits and bytes. Computers store and process information in binary format using bits, which is nothing but zeros and ones. 8 bits make up a byte, which is the basic unit of data storage and processing. Evolution of computer organization and architecture. Over time, computer systems have become faster, smaller, and more powerful due to advancements in technology and architecture design. So, in the below, you have an example. So, the first diagram shows the oldest computers which people were using. Then we have monitor, CPU, and keyboard mouse. So these were also a bit older compared to our latest laptops and systems.